Welcome. In this lecture, I'm going to go through some examples of integers and non-integers, right? So when I say non-examples, I mean something that's not an integer. So let's just kind of get started here. And I'm going to have a little bit of like color notation here. So if I write x is in, and then I do this funny z like this, notice there are two lines here. That means it's blackboard bold. So for x in there, we mean... So what do I mean? If I write that, I mean that x is an integer. So x is an integer. And the picture kind of on the number line, so we have our real numbers are red. So we draw our entire number line with red, and then the integers kind of sit inside of it, right? So we're looking at the numbers like 0, 1, 2, 3, and so on, and like -1, -2, -3. Okay, and so these are what I mean by the integers, are the numbers like that. So then let's kind of look at this. So we have, do we get that? So x could be a number like, okay, so x could be a number like, so I'm allowed to have numbers like, so I can have, so these are the examples, is that I'd have -532 is a good example. Okay, so it can be negative. It can be 0. So it can be this, right? Or, right, we're allowed to have 0. That's a good one. Okay, so 0 is a good one. Or, and then we can have something like 3 squared, right? Because that's just the same thing as 9, right? And so that's good. We're also allowed to have, or we can have something like 4 halves, right? Because that's just the same thing as 2. Okay. So these are all great examples. These all work. What are we not allowed to have? But, so these are my examples. So here are my non-examples, which is that x, now I'm going to do this in red because they're real numbers, but they're not integers. So x could not, so x could not be a number like, so be a number like, and then we're going to have 3 halves, right? So 3 halves, we can look at, sometimes fractions are okay, like this one, when they reduce down to an integer. So, it's good to actually try to go and reduce this down or look at it as a decimal and see that, there's something on the other side of the decimal point, so that's not an integer. Okay. Or another, something that it's not is something like this. Okay. So let's kind of look at some examples of numbers that must be integers. We'll do these in green because they're examples of integers. Okay, so let's look at this here. So examples of numbers that must be integers. Just making sure that this is a nice visible green. Okay, so this is so one example would be, so often you're going to have things that are going to be like an increase because that allows you to also have, if it's a decrease, it gives you a negative. So it can give good examples of where you have negative numbers. As if you're looking for an increase and you get a decrease, and that's a negative number. So an increase in the number of, increase in the number of active cases of a disease. So active cases of a disease. And so, right, and in this circumstances I've kind of mentioned multiple times, is if it decreases, the number is negative. So if decreases, then we get a negative integer. Which is okay. We're allowed to have negative integers, right? They show up on the left-hand side in our timeline, not our timeline, our number line, right? We're getting them over here. That's okay. We also saw an example there. We're allowed to have negative integers. Okay. The other one is to say something like, the car is located X spots to the right of the red car, right? So the car is located X spots to the right of the red car. X spots to the right of red car, right? And now it's like, if to the left, then it's a negative integer. So if to the left, then I'm actually looking at a negative integer. But it's okay. I'm not going to end up with some fraction of a car, just like I'm not going to end up with some fraction of a case. So there, you want circumstances where you can't have a fraction of the thing. And objects are often like this. You can't have a fraction of a car. You can't have a fraction of a case. Okay, so those are great examples of integers. But you don't want things that when you reduce them down, you have decimal places. Okay, right? Because this also, to look at it, this is like minus 3.14, right? So if you have stuff to the right of the decimal place that isn't a 0, then you're in trouble and you're not an integer. Well, you're not in trouble, you're just not an integer. Okay, so I hope that made some sense, and I will see you in the next lecture.